This episode of the EV Resource Podcast is brought to you by Oasis Charging, offering commercial and residential customers comprehensive EV charging solutions with a consultative approach. For more information and to schedule a free consultation, go to oasischarging.com. Coming up this week.
So there's a heat source there, which is happening both during conversion of the DC power in the battery to the AC power used by the motor, and then conversely, because of regenerative braking, the ability to create power when you're not using it, you also get heat created as you are charging the battery as well, both in the inverter that's doing that as well as in the batteries themselves.
Well, hello, friends, and welcome to episode 198 of the EV Resource Podcast. I'm Zach Hurst, and each week I bring you the latest EV news, information, and interviews with industry experts. And this week I have a special guest, Timothy Gotsick. He is the VP of Technology and Innovation at MacDermid Enthone Industries Solutions. They're a global market leader specializing in manufacturing chemical compounds for all surface coating applications. Currently, Timothy holds a Bachelor's of Chemistry from Reed College and a PhD in Chemistry from the University of Tennessee, Knoxville. And actually, I didn't ask you, but I believe you hold a number of patents as well. Is that right?
Yeah, I think about a dozen at last count.
Yeah. So welcome to the EV Resource Podcast.
Thank you very much for having me, Zach. I appreciate the opportunity to sit down with you.
Well, and this is one of those special situations where what you do and what you've done certainly can be applied to so many different areas, but I feel very fortunate to be able to talk with you because what we want to talk about really today is EV batteries, naturally, but more specifically relating to how innovations in battery technology and the design, of course, from a surface coating application that can really be used to provide performance enhancements and thermal management, especially with longevity related to battery cells. So, oh my goodness, like that's quite a mouthful, but I think it's really going to be exciting. Before we get into all of that, I want to give you a chance to just speak to your origin story a little bit, share with the audience how you got to your current position and kind of walk us through that history a little bit.
Sure. Well, so as you mentioned, I have a background in chemistry, and when I chose to go into industrial chemistry rather than academic chemistry, because I really enjoy the applied end of science, using advanced science to figure out ways to make things better. I discovered a long time ago that I really got a kick out of seeing new products that I'd helped develop. I've had the good fortune to work in a couple of different industries and gotten to see products that I had a hand in on store shelves or in use, and that really excited me. And so I've focused on kind of new product development processes in the specialty chemicals industry for virtually all of my career. And this last I think 7 years that I've been in the Industrial Solutions Group has been an opportunity to learn a lot more about a new field of chemistry and a lot of new applications. And the cool thing is, we were talking before we started recording about kind of personal interests, and we're both kind of gearheads and stuff. And a lot of the applications that we get to work with right now are in the automotive and transport sector. And so that's satisfying to me because I'm into automotive and transport. So it's been a really nice combination. I get to work with a lot of really, really smart people who have, in many cases, decades of experience in this chemistry. So some of the world's best chemists, which I consider an honor to call colleagues, as well as I say, working on some applications that have real world basis today and in the future. So pretty exciting and pretty cool.
I realize that I've made somewhat of an assumption when we're talking about battery chemistry based on the small amount of research I did about the company in terms of surface coating application. We aren't talking necessarily about the actual chemistry of the battery in the traditional sense with the electrode and electrolyte and all of that. We're talking slightly differently. So let's, at the very least, start with explaining kind of what the area of work that you do, what that is actually all about.
Sure. It's an important distinction that you bring up. So we don't currently do a lot of work within the battery cell itself. I had the good fortune to actually work with some very early stage lithium-ion battery chemistry back with Motorola, probably about 25 years ago when it was in flip phones. So I'm very familiar with the technology, but we don't work in the battery chemistry per se. Where we come in is that we apply coatings, usually coatings on metal or metallic coatings themselves, on a lot of the other components. And so that can be as diverse as, in a lithium ion can cell, we're involved in some of the plating of the actual, steel that goes around the can, so the actual packaging of that. But we're not doing the anode and the cathode and too much with the materials inside it. That's in some ways that's fairly mature. I mean, lithium ion batteries have been manufactured at scale for a long time, and so that's a pretty well developed market. Where we're mostly involved is in the packaging of the batteries into battery packs, into automobiles and scooters and motorcycles and that kind of thing, and also in some of the componentry that is used to turn the electricity into power torque at the wheels. So we've long had huge interest in the automotive sector. We are a major supplier of anti-corrosion solutions. So every fastener that goes into your current car is made so it won't rust. All of the decorative trim, like automotive chrome, we do that. A lot of specialty coatings for valves and drivetrain yokes, and just almost everything in the car that is a part typically has a metallic coating on it. And a lot of those will stay. I mean, if you think about the rolling chassis of a current car, that's not that different. It's just the way power is applied to the wheels is different. So a lot of basis in the automotive industry, and this is sort of a major transformation where we have some new opportunities to add value in the new systems that are coming to be important in EVs as well as IC vehicles.
And this is something that, believe it or not, even almost 200 episodes of this podcast, I've never really thought about everything that you just mentioned, especially related to batteries and how it's all put together. It's naturally talking about the actual chemistry makeup of the battery has come up quite a bit. Not once have I thought about what that all gets put in and how maybe small changes in the container and how that has been designed and manufactured potentially can make a pretty significant impact.
Oh, definitely. Definitely. There are a lot of good examples of this. I mean, to give a really broad one, like the average age of cars on the road in the US now is approaching 12 years. And in large part, that's due to the fact that the ability to inhibit corrosion and wear in mechanical pieces and things like that has risen dramatically in the last 30 years. And so, it used to be that 100,000 miles in an IC vehicle was considered pretty old. Now, most people are going to be upset if they don't get 200, maybe 300,000 miles of it. And that's because the quality and the performance level that's expected both by preventing rust, which we're in continual war against, as well as preventing wear is so much advanced, so much. So we'll continue to be able to leverage that in EVs because we have a lot of experience and a lot of things won't change. But there are new applications within the drivetrains of EVs where that technology is growing at developing at a much faster rate because it is kind of in a nascent phase of its development from a technology perspective.
What makes that so fresh? And the reason I'm asking is because batteries in general have been around quite a while.
Yeah.
Cars certainly have been around quite a while, and I wouldn't imagine that there's a lot of room to learn a whole lot of new things. What are you noticing that's really something that has got you excited these days?
Yeah, well, I mean, one of the cool things is, we have long worked with material scientists and particularly engineers, mechanical engineers, because they defined a lot of the specifications for what we need to work on. Now we're talking not only to mechanical engineers, but also to electrical engineers. So it brings a whole nother dimension to the things we're trying to do. And that's interesting both because at our customers we're doing this, and it also gives us an opportunity to collaborate with other people within our sister companies. MacDermid Enthone Industrial Solutions is owned by Element Solutions, Inc., which owns several other divisions that work primarily in electronics. So They make circuit boards, they do solder and assembly materials, a lot of really sophisticated electronic assembly things. And we're finding that a lot of these new applications afford us an opportunity to work together. A good example that you mentioned before was like thermal management. So one of the things that's interesting about, particularly the consumer automotive, and I'll lump that in there with, typical automotive cars like we're familiar, automotive vehicles like we're familiar with in the West, but also two-wheelers and three-wheelers are big in other parts of the world, and we sell all around the globe. So we tend to think of vehicles more broadly. But they're high volume production, relatively high volume production for as sophisticated and device as they are. But they have extremely high safety requirements because you're protecting human passengers, and they are high efficiency requirements. Everybody's starting to realize that there's a limit to the amount of energy you want to use. So there's a lot of performance requirements that go into these things that make them interesting. And that affords us an opportunity to use coatings to try and improve the efficiency, improve the safety of the cars. So in an EV, one of the interesting areas, as you mentioned before, is thermal management. So lithium-ion batteries and even the various variants of these tend to operate most efficiently within a relatively narrow temperature range for maximum efficiency in lifetime. And so it's a different temperature range than you get with an internal combustion vehicle, where you have a huge amount of waste heat and the temperatures from ignition are very, very high. So it's a narrower range. You don't have to cope with quite the same high temperatures, but it is important to keep them in that range. And so what we're seeing now is both on the battery side, you want to keep the batteries in the right temperature range, but also one of the interesting quirks, which many people may not realize, is that batteries store energy for delivery as direct current, right? And so that's how it comes out of there. But almost all of the traction motors, the electric motors that are used in cars, are actually AC motors. So there's got to be a conversion from DC to AC in order to drive the car. And that happens through an inverter. And that process itself is not 100% efficient. It's quite efficient, but there's a lot of power flowing through these. So there's a heat source there, which is happening both during conversion of the DC power in the battery to the AC power used by the motor. And then conversely, because of regenerative braking, the ability to create power when you're not using it, you also get heat created as you are charging the battery as well, both in the inverter that's doing that as well as in the batteries themselves. So that's kind of fascinating, because in the battery pack itself, historically, and this is changing beneath our feet as we go on, but historically, like I think the original Tesla battery pack had I think 7,700 individual cells, so little tiny can cells like were in your laptop, gang together to create yep, you got it, the 21,700. And so figuring out how you cool all of those is kind of a fascinating exercise in contact and circulating fluid and all that sort of thing. Now we're seeing more prismatics and pouch cells and that sort of thing, so it changes it a little bit. But basically, you need to keep those batteries cool when they are either being charged or discharging. They both tend to create heat, so that's a challenge. And then also in the inverter. So what we end up getting into is a lot of things that you never even see, but they're actually some very sophisticated technology in all the contact surfaces through which that heat flows. So I'm sure you've seen the interior of like a Tesla battery pack, the early Tesla battery packs, and it's still a very common way of doing cooling now. There's a serpentine channeled aluminum thing that goes around each cell and contacts it on the side, and there's actually a liquid coolant that flows through those. Well, you want to have the most contact there, so you have a thermal interface material. You need adhesion there, so you're typically going to have some kind of treatment on that so that you have good intimate adhesion, which both from a reliability standpoint, you don't want all those things rattling around, but also from a heat transfer standpoint, the more intimate that contact is, the better the heat transfer is going to be. So you see that in the battery packs. In the inverter, that's actually an even more interesting area because the power demands now, as we're seeing going from 400 volt to 800 volt architectures and things like that. The power demand means that you got a lot more heat coming out of there. So people are going from, the conventional, I guess they were IGBTs, are heading up now to silicon carbide MOSFETs for that inverter, and they operate at much higher temperatures. Well, you want to be able to suck the power out of the thermal energy out of that as it's producing this and put it into a pretty conventional liquid based cooling system. And within our company, we are fortunate that we have people who make virtually all of the materials that are used in that entire chain in between the liquid coolant and the chip. So we work primarily on the heat sink itself, which looks like a pretty typical heat sink that you might see. You might have seen it on an air-cooled motorcycle, or you'll see it in a computer, directly on a computer chip. It'll be a pin fin type device. That's what's actually in contact to increase the surface area with the liquid coolant. And then that's treated with a series of metal coatings to prevent corrosion to the heat sink itself, which is usually either aluminum or copper based. Both of them have very good thermal transfer capabilities, and then you need to put some things on it to prevent corrosion of it. And then on the other side, you need to have intimate attachment of that all the way up to that chip that is actually doing the conversion. And so there's usually a series of coatings: nickel, copper, silver in many cases, usually an anti-tarnish, so that part can be made and then be preserved for a while. And then depending upon the application, there'll either be a solder type connection to the bottom of the chip, or in high performance, what we're seeing is that a lot of people are turning to sintered silver products, which our sister company, MacDermid Alpha, makes a product called Argomax, which is one of the leading sintered silver products out there. And that has silver, like copper, has extremely good thermal transfer characteristics. Plus, it can be made mechanically stable to withstand the heat cycles that it goes through. So we work together to ensure that there is compatibility with the liquid cooling medium, as well as with all these other layers that allow there to be a very short and efficient heat transfer pathway away from that chip that keeps it operating at a very high performance level. So that's sorry, I went into a little bit more detail.
Oh, that's great.
Yeah, these applications are really cool because they do kind of blend an understanding of the electronics, which are obviously at the heart of a lot of EV technology, along with the material science that's necessary to connect all these things together to get the desired result, which is, you pointed out, ultimately is high performance and reliability.
Yeah, when it comes to really the electrical systems of electric vehicles, heat is the enemy, right? Heat will require that you cannot apply power over a sustained period of time. And
Exactly.
Traditional gearheads that haven't quite made their way over to the EV space yet, one of the biggest complaints is, well, sure, it can go fast in a straight line, but put it on a racetrack, and after 5 laps, you've got reduction of power. I have run into this myself just testing EVs, where within 2 laps around, I've got a track about an hour north of me, Dominion Raceway. It's a 2-mile road course, fairly lower speed and technical. So it doesn't put a lot of that demand on the drivetrain or battery pack the way some of the long straights at like Road Atlanta or some of these other really much bigger racetracks. Well, it can't. I've been in some cars, and I won't name them, but they can't even make it 2 laps without things getting derated when it comes to the power and the current that it'll allow to flow. Very frustrating. So that's one of those complaints, if you will, from the motorsport community that I'm going, yeah, there's something to that. But as much as you and I are gearheads, the general public as a whole probably would care more about safety, because certainly heat inside the battery pack we've seen that result in some fairly catastrophic failures
Yep.
where if you can manage that even separately from coolant or even Bugatti, I believe I ran into recently is exploring an immersion of battery cells directly into, I believe it was some sort of dielectric oil.
Yep.
Well, that's important. And certainly I
Yep.
think that takes the central role of removing heat. But everything that you've shared, it I wouldn't even say it plays a supporting role. I'd say it's right up there next to it because you can move heat through a liquid, but there are some situations where you don't have the physical space. And the
Yep.
inverter is a great example of that. Yes, you can have parts of it be liquid cooled, but not everything, not everywhere, especially not once you get down to that circuit board level. Well,
Hmm.
I don't know anybody that's just throwing a whole circuit board into some sort of liquid cooling. So there's got to be some partnership there.
Yeah, definitely. And I mean, one of the cool things is I think motorsport often provides an interesting test bed for these sorts of things. And so I suspect you follow Formula E. I'm, like I say, a two-wheel guy, and so I follow Moto E
Yeah,
as well. And those are interesting places where there you're freed from some of the constraints. So right now in consumer products, there's usually some level of compromise that's being made. You need to have more range. Cost is more of a concern. Once you take some of those out of there, you get to see what people can really do. And so I think those are interesting test beds to see what's possible. There, I think that the problem of thermal management is not fully overcome, but it's certainly advanced a significant amount. And so you see Formula E cars now being able to race 45 minutes uninterrupted. But way back in the day in 2014 when they started, they had that crazy thing where they would actually pit and switch cars in the middle
yes,
because they'd run out of charge. Now they're able to do that. Now it's a purpose-built vehicle, and they do limit the power on them, by the rules. So there are some sort of unnatural constraints, but it is proving to be, I think, a really fertile test bed to show how far you can push some of these things and what is going to be practical. And as usual, I think we will see that trickle down into some of the vehicles that we drive. The continued use of hybrid powertrains and supercars, hypercars, is also very interesting because that's another place where you kind of take away some of the limits and you can do some pretty crazy things in order to maximize output. So right now, one of the things that's holding it back is that the availability of the batteries. The price has gone way down because they are manufactured in volume, but there still is an economic incentive to use a standard format. So if you use one of the standard cells, you do have to have this problem of like, okay, I got to have a crazy serpentine bath, or I got to have cooling plates or whatever, and so it's necessarily a compromise there. As we go into some of the new architectures with pouch cells and that sort of thing, there have been instances where people are actually running cooling plates in between the pouches, so you get extremely good cooling. Unfortunately, that goes against the energy density that you're trying to get at, and so again, there's still a lot of experimentation going on. I'm confident, like I say, we're on the still on the steep part of the technology development curve. If you look just at things like cost of batteries and that sort of thing, they have plummeted in even the last 10 years.
oh
And
yeah,
so I think that we're going to see a lot of interesting innovation. And we're eager to work with people who have novel ideas about these things, because we do have, if somebody comes to us with a challenge that says, all right, I have an interface of these two things, how can I make them work together? That's where we're able to kind of roll up our sleeves and say, all right, we know all the metal coatings that go on this. We know the ways that you can attach to them. We can work together to design these things. And the heat sinks to interface with a silver sintered material is a great example of that. That adhesion has to be perfect. You want a perfect heat path, you want no voids there, you want excellent adhesion in order to make that both reliable and high performance. And that's kind of where we come in. It's mostly in the parts that you either never see or that you look at and don't think anything about. But there's a lot of material science that's going to go into that.
I absolutely love where this conversation is going. We're going to take a quick break and then we'll be right back at it. Turn everyday shopping into savings with the Upside app. Whether it's fueling up, grocery shopping, or dining out, Upside lets you earn cash back on your purchases without limiting how much you can save. You can even combine it with other coupons, discounts, and loyalty programs, so it's a win-win for both you and the business you're buying from. So buy what you need and feel good about it. For more information and to download the app, click the link in the show notes to support the EV Resource Podcast. Hey, everybody, I just want to thank you real quick for watching, listening, and supporting the show. Your support is what keeps this show going. If you want to access all the URLs, codes, deals, and discounts by our partners, you can head over to ev-resource.com/deals. Please consider supporting those who support us. Would you say a lot of the innovation is a result of using existing processes and materials and applying them in new ways, or is it actually getting much more specific on the chemical level and developing new coatings to apply to existing situations?
Yeah, it's a little bit of both, but at the moment it's mostly taking what we have, because it's actually an industry that's been around for quite a long time. We've confronted a lot of challenges, so we do have a lot of existing solutions in our toolbox, and so a lot of those are being applied immediately now, particularly in the environments where there is sort of a need for that compromise. People are trying to drive the cost down. Obviously, reliability and safety are major factors, and so we do that. And it happens in some interesting ways. So in addition to like the thermal management that we just mentioned, for instance, with safety, we are involved in some projects where the actual box that holds the batteries, I mean, sounds pretty prosaic. It's just literally, it's a box. They're usually mounted on the bottom of the car, which is a fairly aggressive environment. You're going to have a lot of those exposed to road salt and things like that. That's right in our favorite zone. We fight corrosion, so we're very good at that. So we have a number of those things. You also have the issue of the passenger compartment is right above you, right? So if you do have an adverse event, which are fortunately becoming less and less common, you need to make sure that you protect the occupants. So a lot of the battery boxes have been aluminum for lightweight and ease of manufacturability. What we're seeing is that in some cases, people are actually choosing to make the top of the battery box out of steel, which is heavier, but it's also relatively inexpensive. It's highly manufacturable. And we are expert at treating steel with coatings that are completely impervious to heat. They prevent corrosion. They're metallic by nature. And so they are not going to be affected by heat. And that provides, kind of like what the firewall does in an IC vehicle. That provides a very, very safe environment where even if there is, all hell breaking loose in the battery box, it's not going to get through that lid. And it's also going to be able to withstand any amount of corrosive environment that they may experience from being on the bottom of the car. So that's just another example of, like I say, you don't think about that a lot, but that is the sort of thing that a lot of the automakers are going through as they try and balance safety, reliability, performance, and cost in these. And we have a lot of existing solutions that can be used in this. I think as we see the technology improving, and people climbing that curve, that we do expect that to be well positioned to be working with the people who are innovating in that space and saying, I suddenly discovered that I can do this with this electronic or mechanical component, but I need to attach it to this, or I need to protect it from this. And we're actually looking forward to the time when we're going to be confronted by those new challenges. I've got a great staff of R&D scientists who live for that kind of challenge of saying, wow, all right, I don't know how to do this, but I want to figure out how.
Yeah. Yeah. I imagine that in many ways, the future being somewhat uncertain in how battery electric technology is applied, even beyond road vehicles. I know the aviation and even Marine industries are also working through the beginning stages of electrification.
Yep.
Naturally, the two of those have very separate needs that they would want to focus on, but either of them, safety, thermal management, power, longevity, all of those things still play a role. Being able to work through a lot of the things that you mentioned with cars and the passenger
Hmm.
compartment. Well, with a boat, clearly, you need to protect a lot of that space, both above
Yep.
as well as below. As far as I know, they're still making boats out of fiberglass or some sort of carbon composite or something. So
Hmm.
that could be affected by excess heat if a battery pack
Absolutely.
or inverter or any of those components is not being managed from a thermal aspect properly.
Hmm.
But you get to airplanes and the risks kind of go up a little bit. So, that definitely, I can see the what is learned now and how it's being applied and the feedback on kind of the development of not only the technology as a whole, but certainly down to the nitty gritty details of how pieces are adhered together.
Yep.
That the application of that can really, I mean, the next 30, 40, 50 years easily. And then who knows, maybe aerospace and getting involved with things outside of the atmosphere. Um, I can only imagine you'd never run out of new problems to solve.
Oh yeah, not so far. Not in my there's twists on things and there's interesting application development. But yeah, I mean it was funny. I got a chance. I ran into a guy from Archer Aviation, which is one of the companies that's looking at producing electric VTOL for transport. Basically from urban centers to airports and that sort of thing. And got a chance to ask him about how they were doing it, and it was impressive. I mean, obviously, we do a lot of work with military and aerospace as well, because there's a huge amount of specialty coatings that goes into that too. But the design, I was surprised. I mean, there's going to be more redundancy and stuff, but the design is not that different than what you might expect. I mean, it's not radically different, but obviously, in those applications, the standards are usually a little bit higher. Like you say, if you're a few thousand meters in the air, it going into limp mode is not really an option. And so there are going to be higher standards for some of those things. But it is really cool to see that people are pushing the envelope on the application of this technology. And this fundamentally comes down to the fact that lithium ion batteries, and I think there's going to be whole generations of other battery technologies that are going to take this even further, have reached a point in their development where their energy density and reliability has reached a point where these things can be done. And so you start to see the fast charging capability that people are able to do now, the sheer size of the battery packs that people are generating, and it's going to be a rich field for development as we confront new challenges that are posed by the desire to push the envelope on where electromotive can be placed.
If you're able to speak to it, what's some an application of the work that you're doing that you're most excited about right now?
Well, the thermal management really is the cool part, because it's exciting on two levels. Number one, it is, as we said, a key part of the success and the reliability of these vehicles in whatever application. The other thing there is that, again, between Industrial Solutions and our colleagues at Assembly Solutions, we're getting to do a lot of really cool collaboration. So we have lines of electroless nickel, our NiClad, our Innova products, and things like that that are at the core of some of the protection for the heat sink. And then, our copper products and our silver products and that sort of thing. And then they have this unique sinterable material for these high performance applications. And so I think most scientists really enjoy getting to learn new things, getting to collaborate with other scientists working at a high level. And so this has been a really exciting area for us to be able to work at that. And then conversely, that use of that sort of highest end performance thing with a silver sintered material is going to be right for certain applications, high performance, high reliability. But also, I have a research group in India. I go there on a couple of times a year, and there the market is going to be much more about two-wheelers and three-wheelers and that sort of thing, and it is going to be a lot more cost sensitive. So there's plenty of challenge to be had in those markets as well, where it's just a different set of constraints, but you still have to use all your intellect and experience to figure out, all right, how do I, overcome those constraints? So there, you're going to be talking about things like, all right, it needs to be really low cost. The range may not need to be as long. In two-wheelers, you have things like you can do hot swappable batteries.
Right.
That's becoming a thing. And so it removes that problem of fast charging, but now all of a sudden, you need to have a canister that is protected from abuse and is going to be fairly durable, and it's going to get swapped out. So there's going to be contacts that need to be prevented because it's going to be going in and out all the time. And it needs to be relatively cheap and lightweight. So it's a whole different set of challenges, but no less interesting to overcome. And if you think about the impact that has, I mean, if for people who haven't been there, the sheer number of people and scooters and three-wheelers in India is kind of shocking. And there are more two-wheelers made in India than there are cars in the rest of the world. So the
Wow.
numbers are staggering in terms of the impact you have. If you electrify, 50% of the two-wheelers and three-wheelers in India, like, you have a noticeable effect on the air quality and the CO2 output of that entire nation. It's really very cool. There's actually a lot of really interesting innovation going on there. Huge number of companies looking at battery manufacture in India, electrification of existing two and three wheelers, as well as like all of the two-wheeler manufacturers there are getting into this space. So it's kind of cool. It's invisible to a lot of people in the United States because this is not a big market in the United States. But it's cool to be able to see that, and I think it is going to filter down into other applications and in other markets that are going to be important.
It's interesting that you say it's invisible to most people over here. I am very guilty of that. Like you're saying all of these things, and I'm going, the only manufacturer in India that even comes to mind in any way, shape, or form is Tata Motors. And I'm going, oh my God, like I am realizing I probably need to learn a lot more about what's going
Well,
on in India
so
specifically.
it's actually really interesting. So I mean, we mentioned before I'm big into motorcycles, and so I got to visit a company called TVS, which I'll confess I honestly had not heard of before. TVS is the third largest motorcycle manufacturer in the world.
I got to look this up.
Yeah, I mean it's really cool. So I've gotten a chance to visit TVS and Ola and Ather and a lot of these companies that make scooters and motorcycles and two-wheelers in India that are actually enormous. I mean, absolutely enormous, and supply heavily into not only the domestic market in India, but also into Southeast Asia. You go to parts of South America, a huge number of two-wheelers in urban traffic there, things like that. So it's a huge market. It's a very, very different market than what you see in the United States and Canada, which is what most of us, sort of live and drive in on a regular basis. And it's interesting because, as they say, there is a lot of innovation being applied, different set of constraints that you have to respect to be successful there, but no less intellectually and challenging and from an engineering standpoint.
Yeah, I like this company TVS. Their webpage, the first displayed image is talking about performance and going fast. So clearly,
there's some really cool little bikes there. I mean, it's
oh wow, yeah.
Another one that's huge in India is KTM. KTM, you see KTMs
Okay,
there
yeah.
all the time. I mean, they're kind of, you see them in the US now, they appear every once in a while, but they're a major, major player there. Really cool sporty thing. So I used to, when I was younger, I used to lust after all of the low displacement motorcycles they had in Japan, because Japan's licensing laws,
Yeah.
Basically a big motorcycle was 400 cc's there. And I grew up riding CB 400s and things like that. So I always loved those things. Well, India as well as Japan are really cool for seeing these little things where it's a relatively small motorcycle, but it often includes all of the really cool technology that you like in these things. So kind of like European cars, same thing, very small,
Mhm.
but oftentimes even something you look at and say that's a small car will have a ton of features in it that you would only expect to see on a high-end car in the US because
Sure.
it's a standard car there.
Yeah, and as we look at a lot of these areas electrifying some of these, um, I guess we could call them e-mobility with some
Mhm.
of the smaller
Yep.
vehicles. I would imagine that gets really exciting because when you turn to an electric motor with a
Mhm.
battery pack, it gives you so many more options for the overall vehicle package where you can fit something really powerful into a small space. I can only dream of some of the applications that
Oh
might
yeah.
be taking place.
Yeah, I mean, we're going to see all kinds of innovation because of that. The limiting factor right now, particularly in two-wheelers. So, I mean, the whole reason for being for a motorcycle is lightweight. That's their attraction. It's
Absolutely.
lightweight, a lot of power. And the limitation right now in motorcycles is that the energy density in the batteries has really not reached the point where you can quite take full advantage of it. If
Mhm.
you look at like the Moto E bikes, for instance, they're relatively heavy compared to their Moto GP standards. So I think the Moto E bikes are around 225 kilograms or something, and more than half of that is the battery. In order to be able to go 8 laps, it's a very short race. They're incredibly fast. I mean, it's got 150 horsepower electric motors, so these things are blindingly fast by any standard sort of power to weight ratio, but they're really limited in their range. So that's going to take a while to overcome. It's not just efficiency; it's just simply the watts per liter that you can get into the battery
Sure.
pack is limited. In a three-wheeler or a four-wheeler, and we see this in automobiles here in the U.S., you don't have quite that limitation. The EVs are typically heavier than you would expect for their size because they have a large battery pack, and that's why they tend to go through tires a little bit faster. But in some of these markets, they don't require the same amount of range. So, if you want to run a three-wheeler in urban Bangalore, you don't need 300 kilometers of range for it to be an effective delivery vehicle for goods or passengers,
Sure.
particularly if the charging infrastructure is widely available. You also see some really cool things like in India, there's a company that I got a chance to visit called Log9, and they're kind. I think they are financed by I think major backing from Exide. I could be wrong about that. The Exide, the battery maker in India. But anyway, they are both manufacturing cells in India now, as well as electrifying a lot of three-wheelers. And if you go to the Indian market, these three-wheelers are ubiquitous. They're everywhere. And they're the little tuk-tuks. They have
Yep.
very, very low-powered internal combustion engines, and they make a very distinctive sound. And they go very slow on hills because they don't have much power. Um, well, the interesting thing is they're converting a lot of these things over. They're not wildly innovative in terms of the power. It's an electric motor and it's a battery pack and all. But one of the cool things that they've done is they actually have some of these retrofitted where it's basically a giant stack of batteries. So it's a mobile recharging station. So what happens is that if you do happen to forget and go and run out of power, this thing comes to you and charges the thing, which is another way of addressing, the range anxiety issue. And in a dense urban environment, that's actually a workable sort of, last gasp sort of solution in that market. So they say this is what's kind of cool is seeing the different constraints that are there and some of the constraints that don't exist fuel thinking that I think is going to be fascinating to see how that works. Hot swappable batteries are another example. So in a motorcycle, obviously the battery pack is smaller, and so you can actually pull it out and put it back in. So it's a good solution there. But in China, you have NIO, who makes
Right.
some really nice cars. They actually, and I've had the opportunity to be in a NIO vehicle in China. They also do hot swapping there
Yep.
of these in a full size SUV where
Right.
you go to the computer on there and you say, what's the nearest battery swap station? And it tells you, and you schedule the appointment, you drive up at the right time, and it takes 10 minutes. The whole battery pack comes out of the thing. And we're talking about, we're not talking about a, 4 kilowatt hour
Oh
battery
no,
pack. We're
like
talking about
100
something
kilowatt
like,
hour. Yeah.
yeah, they're big. It drops it out, puts it back in, and you're on your way in 10 minutes. It's kind of remarkable. I don't know if that's scalable. I mean, the Chinese EV market is so hot right now in the sense of everybody competing for market share and all, that they're doing some kind of wild stuff. And I don't know if it'll take off. Because I mean, think about it. You want to put those in, you got to put them everywhere. You got to have 10 batteries in each one. You got to have power to charge them all. It's no small feat, but there's like 10,000 of those installed in China.
Right.
And it also means that the battery lifetime per se, your battery pack lifetime, that worry vanishes because you get a new one every time you go.
Right.
And so it's interesting to look at some of these things. This is it's very cool being able to observe a market that is this dynamic and this nascent, to see all of the innovative thinking that's coming in about it. And it's another example of a place where, we have a role to play with surface coatings, because if you're going to do hot swappable batteries, you're going to have connectors that have to be, super reliable in an automated sense in order for that to work. And so that's, again, where we come in, where we need high conductivity, high wear resistance in those plugs in order for that to be a workable solution. So they
That
say little
is
things you don't think about a lot, but that's kind of where we earn our money.
surprisingly, I think about that probably more than most people. In fact, the most recent episode that would be published before this, I actually talked about. I'll show you. It was all about EV charging and creative at uses at home. Well, this is a dryer outlet from the 1980s. And this is what I was unplugging the dryer, plugging in the car charger, unplug, plug in 1-2 times a day for well over a year. And I don't know if it comes across on the camera very well without getting the lighting different, but right in here, especially this one, is very charred. And
you got a lot of arcing there.
Oh yeah. So anytime you're talking about plugging and unplugging and plugging and unplugging,
those
what you do is so important to keeping things not worn, because the more you wear it, the more it arcs, the more resistance there is, the more heat. I've mentioned this a few times now, but I keep this next to me because it reminds me that I could have burned my house down and killed my entire family because I wasn't thinking about that aspect of it until it really was right in my face. So yeah, what you do, even for that, it's important because, to your point, most people probably don't think about it, or even if they're fairly educated, like I would have really liked to look at myself at that point. You can still overlook some things that, luckily for my sake, I was able to catch it. But, just the little things can really get to a point that it could result in some pretty significant problems.
So the good news I can relate is having had the opportunity to talk to a lot of people who are designing these things. They are laser focused on making sure that they're safe and reliable. I mean, if you actually go and study the stats, the number of EVs that have erupted in flames is relatively small. Gas cars do it all the time. Just everybody's accepted it as like kind of the price for having all this. But they are very, very concerned about it. And so they do bring problems like that. Whereas the designer of that outlet that you looked at there figured it might get unplugged a dozen times in its life, right? That was the duty cycle. Whereas now, when somebody looks at, the charging connectors in a standard CCS connector, or I'm sure it's true of an NACS connector, they're figuring, okay, that's probably going to see 5,000 to 10,000 cycles minimum over the course of its life. And so these things need to be designed both to have the super high conductivity that you want, so you don't lose any of that power in that transition, as well as, a reasonable insertion force and a resistance to wear that's going to mean that it is completely safe the 10,000th time you plug it in as it was the first. So
Public
that's kind of
charging,
reassuring.
it comes to mind, where you literally are putting a connector with its purpose is to be plugged and unplugged,
Yeah.
hopefully a lot for the sake of the company that's operating it.
Yeah.
Yeah. Oh my goodness. There's another application I never thought about, that coding and the importance of how that relate. Very cool. Very cool. Like,
A lot of the little parts. We deal with the little parts that add up. And so that's important. Actually, another one that's a little more prosaic, but you'll understand this is, we mentioned before that EVs tend to be heavy because of the batteries and stuff. And what's interesting is, because you use regenerative braking most of the time, your brake pads probably will never wear out. I mean, in many cases, because you just don't have to use them all that much. However, when you do need them, EVs all come equipped with brakes that are of a size that will be able to stop a relatively heavy vehicle from a high speed in no time at all, right? And so, we have been working to put finishes on brake calipers and brackets and all that sort of thing for, the last 50 years. And it's very advanced, super high anti-corrosion capability, coatings on them that ensure that they're highly unlikely to vibrate loose or to have any of those fasteners come loose as a result of the thermal cycling the brakes go through, very high temperatures, very cold temperatures, water splashing on them, things like that. So we've been working on those things for many, many years. They transfer over and actually ensure that, hey, when you're designing an EV, you won't have to worry about the brakes, because we already have great solutions for those. So you can concentrate. And this is one of the reasons, again, why the technology development curve is so steep. EV manufacturers are able to piggyback off of 50 or 75 years of material advances that have led to, the highest performing, safest automobiles that anybody's ever seen, and they can concentrate on the drivetrain and the development of that. So that's where they're working. The rest of the problems are, I won't say they're all solved necessarily, but they're certainly a lot further along and already demonstrated safe and effective for doing all these things. So that's where they're concentrating their time, because there's also going to be a huge amount of value that they're going to add as they solve those problems.
I realize especially when you were mentioning the brakes, it would seem I've been doing this podcast long enough for things to start connect to former podcasts. Back March of last year, so it's coming on a year and a half ago, I had a podcast where we focused on the brakes, specifically with the application of brake pads and materials that were used in ICE vehicles on EVs, and where the problem was not getting used. And so because of they didn't get exposed to the heat cycles that they were designed to, they were starting to break apart and corrode. So I was talking with a company that was working with a physical friction attachment of the backing plate to the friction material, the brake pad. So it's just fascinating, because like, here we are, a year and a half later, and it's something that comes up again. So this is really cool, and I can tell that we could probably go on for quite a while. I do try to keep, for the audience sake, the podcasts to roughly 45 minutes to an hour or so.
I understand.
So definitely, I think we've covered a lot, and I'd love to work towards wrapping that up.
Okay.
What would you say, is there anything that really kind of is the big takeaway from the conversation that we've had that you want the audience to remember?
Yeah, I mean, I think the thing to remember is that there are a huge number of parts, all of which, in an EV may have slightly different application conditions. And this is why it's valuable to have, providers like ourselves who understand the materials and how to apply them, so that we can adapt the parts to work in the application. And you know, your example of the plug is a great example of it. That plug was designed for a particular kind of use, and it was perfectly good for that. You were using it in a different way, and all of a sudden it wasn't so good for that.
Yeah.
And that's why we tend to work really closely with the designers and the fabricators of these things. So we really understand the application and can provide the right coatings to make sure that, you know, you have the maximum efficiency, the maximum safety. There's always an element of cost that comes into this. So it's that domain expertise, I guess, that comes in that's so important in surface finishing applications, because we got a big toolbox, we got a lot of experience with it. What we need to know is, what do you need? You know, what are the conditions of use? And then we can often figure out unique ways to bring things together that will help address those needs. And yeah, I mean, the big advances that may come, you know, they may be in traction motor technology, they may be in these inverters, allowing things to be able to, you know, hold you know, higher voltages, higher power outputs for longer. We're going to be able to support that from the industrial solutions part, and then our you know, colleagues in the electronics area are deeply involved with a lot of those things, because obviously EVs are becoming you know, rolling electronics beds, and are probably going to be, you know, they're going to have a lot of them are going to be differentiated in the same way you try and differentiate a phone. You know, it's going to be
Yeah.
the user interface and things like that, as well as the performance. So we have a really cool array of different technologies and capabilities that are going to be able to address these new challenges as they come up. And it's a really exciting time to be interfacing with people who are sort of creating the future in front of our very eyes. This is exactly why we get into technology, right? Because we enjoy this sort of challenge and figuring out, how do I take what I know, make new things, and you know, kind of continue to stand on the shoulders of the giants that came before us to advance the state of the art.
Timothy, I like to end each interview asking two questions. And most of the time, when I'm asking them, I don't already know the answers. In
Okay.
your case, I already know. And so it's partially frustrating, because these are supposed to be like really illuminating, revealing questions in one form or another. I'm going to ask them anyway, because the first one, even though I believe you had mentioned it before we started to hit record, so the audience doesn't know.
Okay.
But the second one we've answered multiple times, and it'll make more sense when I ask it. We don't need to necessarily elaborate further than what I believe we have, unless we haven't. So
Okay.
let me go ahead and ask these. The first one is, what do you drive?
Okay. So I drive a lot of things. Like many Americans, I have a pickup truck. I have a Chevy Colorado pickup truck. That's the work truck that we have. We live, as I mentioned before, I live in a fairly rural environment, so four-wheel drive and dealing with snow is something we need to do. The second vehicle we have is a Chevrolet Bolt, which is a battery electric vehicle, which we are very happy with. Have been very, very pleased with. It's first all electric vehicle we've had. Prior to that, we had a plug-in hybrid, and was so happy with that we went the full boat. So that's been good. I also have a Yamaha motorcycle, and I have a Kubota tractor.
All
So
right.
those are the powered vehicles that I
Yeah,
drive.
sure, sure. And the second question, and it'll make sense now. It's related to the kind of a play on words of what do you drive, where instead of what do you drive, what drives you? So the purpose of that conversation is really, when you wake up in the morning, what is it that gets you going, that full of life to do what you're doing? Um, if you feel like we haven't addressed that and answered it already, feel free
Yeah,
to
I,
continue.
I
But
think Yeah, I think I've touched on it. I mean, we've touched on it pretty good. I mean, you know, I'm at heart a technologist, and I have certain other interests that are sort of hobby level, particularly as it comes to vehicles. And it's been nice to have an opportunity to combine the two, because I'm working on technology that I see on the road that I'm going to buy. You know, and that to me is exciting. I love the practical application of technology. That's kind of what drives me. And this is they say, a great opportunity to practice it.
Awesome. Well, Timothy, it has been an amazing, amazing conversation.
Yeah,
Um,
likewise.
I this is one of those areas that now that I know what you've shared, it's really going to be eye-opening and in some ways change how I look at some of the application of the technology. Because in the back of my head, I'm going to go, ah, those things had to be put together. Like there's
Yeah,
those little details that until somebody shines a light on it, you just never think about.
yeah.
So I want to thank you for joining me. This has definitely been illuminating.
Good. It's been my pleasure too. I really enjoyed talking to a fellow enthusiast in this area and a knowledgeable one at that. So it's been a distinct pleasure for me as well.
Thank you. I really hope you've enjoyed this episode. Thank you so much for watching and listening. If you haven't left a rating or review for the show on Apple Podcasts or Spotify, I'd really appreciate it. And if you have any feedback for the show, questions for me, or just want to say hi, you can email me at hello@ev-resource.com. The EV Resource Podcast is a production of EvoSpark Media Group and is supported by viewers and listeners just like you. Supporters of EV Resource on Patreon are at the director tier, Rajeev, Narayan, and Andy Cooper; at the executive producer tier, Christopher Lawrence and Dave Laansma; and at the producer tier, Eric Weber and Tony Stuntz. If you would appreciate ad-free episodes of the podcast, free EV Resource merch, support recognition, and a whole lot more, you can go to patreon.com/EV Resource. I've been your host, Zach Hurst. Thank you so much for watching and listening, and we'll catch you next time.